Today we will be in Chapter 10, Section 1, Solving Linear Inequalities in One Variable. Our three topic objectives for today are to solve inequalities, solve compound inequalities involving and solve compound inequalities involving or. Chapter 10, Section 1, Solving Linear Inequalities in One Variable. Please note that this section is a lot like chapter 1.5. So if you need a little bit more of a refresher, that's a great place to go. So first we need to understand what the symbols mean. So this symbol means greater than. This one is less than. Then you're going to have greater than or equal to, which is the greater than symbol with a line underneath. So logically you would know we're going to have a less than or equal to. Okay, so a lot of times it gets confusing on which way these open. So remember from 1.5, it always opens to the bigger number. So if we have 7 and 5, we're going to have our symbol opening towards the 7. Alright, so let's define what an inequality is, since that's what we're going to be working with today. So an inequality is a mathematical expression containing one or more of these symbols, the ones that we just did above. Okay, here's a note. You're going to solve these the same way as equations with one special rule. So you're going to solve these exactly like you would if they were an equals equation, except with this one special rule. If you multiply or divide by a negative number, you must flip the sign, or must flip the symbol. This is very important, and it's one of the things that a lot of people will forget to do. So I would star this, highlight this, circle this, whatever you need to do in order to remember that. And I'm going to do an example right off the bat so you know what I'm talking about. So here's an example. We have negative 2x plus 3 is less than 5. So we need to solve this, and we're going to solve it just like we would if this had an equal sign. So we're going to get the x by itself. So we're going to subtract the 3 over to leave us 2. And then I need to divide both sides by this negative 2. So then we have an x, but we divided by a negative number, so we need to flip this sign. So instead of less than, we need to switch it to greater than. And then 2 divided by negative 2 will give us a negative 1. So when I say flip the symbol, that's what I mean you have to do. Alright, let's do another example. We have 5x minus 7 is greater than or equal to negative 17. Again, we're solving this just like we would a normal problem. So that means we would add 7 to both sides. We'd have 5x is greater than or equal to negative 10. You need to divide by 5. So we have x is greater than or equal to a negative 2. Do one more. Example. Negative 6x plus 4 is less than negative 14. Sorry, I'm trying to keep my paper straight for you. So we're going to subtract the 4, subtract the 4. So we have negative 6x is less than a negative 18. Notice this is just subtracting, and you can subtract and you don't have to flip the sign. It's only when you multiply and divide that you have to flip it. Now we need to divide by a negative 6. So right here's where we do it. We had to divide by a negative, so we need to flip the sign. Negative 18 divided by a negative 6 is going to be a 3. Okay. Let's move on. Now there are different ways to represent inequality answers. So I'm going to show you those. Because your homework's going to ask you for more than one way. Okay, so the first one is called interval notation. Alright, interval notation, we have x is greater than or equal to 5. And a lot of times on these problems you're going to have a picture to go with it, or you're going to have to pick a picture. So if we have greater than or equal to, that'll be a filled in bubble. And then x is bigger than that, so that means it's going to be everything to the right. It's going to be shaded in. So that means that we would have a closed bracket, a 5, and then it's going to go off to infinity. This is called interval notation. You use the closed bracket when you're doing greater than or equal to or less than or equal to. So you'll use these brackets with greater than or equal to or less than or equal to, because that means you're including this 5 in there. This 5 is going to be included in this set. And then you go all the way out to negative infinity, and you use a parenthesis because you're never actually going to reach the infinity. That's one of those weird mathematical things. Alright, let's do another one. What if we had x is less than 3? Let's look and see what that would look like on a graph. Whoops, that's a 2, not a 5. Okay, so this time it's just x is less than 3. So this 3 is not included, so you're going to have an open circle at the 3 because you're not including the 3, and then it needs to be less than. So we're going to go to the left or the right of the 3 to get less than. We're going to go to the left. So that means everything over here would be shaded. So if we need to write this in interval notation, are we going to ever reach like positive infinity? No, we're not. The biggest our number could ever be is really close to 3. So that's going to be on our big end. And we're going to just use parentheses because we're not including that 3. Now, what's the smallest our number could be? If x is less than 3, what's the smallest x can be? We don't know. It can be negative infinity. It can keep going down and down and down. So this would be how we would write this. Parentheses with greater than or less than. Okay. Let me do another one. What if we had 2 is less than x is less than or equal to 6? And I need to write this in interval notation. So this is a combined one, and it's okay. X is bigger than 2, right? So 2 is the smallest that x can be. So 2 is going to be on our low end. Can it ever hit 2? No, because it's just 2 is less than x, so it needs to be in a parenthesis. Now, what's the biggest x can ever be? X is less than or equal to 6. So 6 is on our big end. And then since this is less than or equal to, that means we're going to use a bracket. So this tells me that x is in here. X lies between 2, but it is never actually 2, and 6. And it could be 6. It's times like this that I really wish I had you all sitting in front of me, so I could either see the blank stares where you're not getting this, or I could see that you guys are understanding and need me to go faster. But alas, this is what we have. So, in this case, we have negative 6 is less than or equal to x is less than or equal to negative 1. So the lowest is, like, you can kind of write it out like this if you want. And then we just have to figure out what the ends are. This is less than or equal to, so that's going to be a bracket. And this is less than or equal to, so that's going to be another bracket. And this is interval notation. Let's work a problem so I can show you. We're going to work a couple problems. And then I'm going to show you a different type of notation. Alright, here's an example. We have 2 times x plus 1 is less than or equal to 7 plus x. So we need to solve this and write this in interval notation. So first thing we got to do is get rid of our parentheses. So we're going to distribute. And then we need to get x by itself. Again, if you keep your x's positive, that'll be easier. So I'm going to subtract x over, which will give me x plus 2 is less than or equal to 7. Subtract your 2 over, you get x is less than or equal to 5. So for a interval notation, we need to write this out. X is less than or equal to 5, so 5 is as big as x can be. And since this is less than or equal to, it's going to be a bracket. What is the smallest that x can be? We don't know, it just has to be less than 5, so it can go all the way down to negative infinity. So that is the interval notation. Now, let's do another example, because there are 2 kind of special examples, and I want to show them to you. If we have 2 times 3p minus 5 plus 9 is less than or equal to 8 times p plus 1 minus 2 times p minus 3. Okay. Let's look. We have to simplify this all out so we can figure out what our answer is. So I'm going to distribute my 2 in. Sorry for the noise outside. Somebody is drilling. So let's distribute our 2 in. We have 6p minus 10 plus 9 is less than or equal to. Distribute our 8 in. 8p plus 8. Distribute our negative 2 in. That'll be minus 2p plus 6. Let's combine our like terms where we can. So we have 6p minus 1 is less than or equal to 6p plus 14. So let's get our p's together. So we subtract our 6p over. That leaves us with negative 1 is less than or equal to positive 14. Notice we don't have a variable anymore. So, but we need to see if this is a true statement. Is negative 1 less than or equal to 14? Yes, it is. On the number line, negative 1 falls to the left of 14. So that means that no matter what our p is, this is going to hold true. So in this case, it does not matter what our p is. So our answer would be everything, negative infinity to positive infinity. So this is kind of a special case. If you work through your whole problem and you realize that you get rid of your variable and your statement is still true, then it's going to be all the numbers. Now, obviously, if that's going to happen, then there's going to be another example where we're not going to get a true statement. So let's do another example. That is 6z plus 1 is greater than or equal to 2 times 3z plus 4 minus 1. So we have 6z plus 1 is greater than or equal to, we're going to distribute in our 2, which will be 6z plus 8 minus 1. So 6z plus 1 is greater than or equal to 6z plus 7. Subtract over our 6z, we get 1 is greater than or equal to 7. Is that a true statement? Is 1 greater than 7? No, this is false. So this is not going to work. No matter what you plug in for z, this is not going to work. So you're going to see what's called the empty set, which is like a 0 with this line through it. Empty set. Which means nothing is going to work in this case. So those are two special cases that you're going to see like that. Okay, so this was all interval notation and just working through inequalities. So let's do the other type of notation that you're going to have to use, and it's actually much easier. And this one's called the set builder notation. So what this one says is if you have, for example, like x is greater than or equal to 2, in our interval notation we would have done negative infinity to 2 with a bracket. That's our interval notation. Our set builder notation is curly bracket x with a vertical line, and then you're going to have x is greater than or equal to 2. That's it. This is your set builder notation. And what this reads as, it says x such that x is greater than or equal to 2. That's how you would read that in words. So, let me pull up. Let me go back and find one. So if we were doing negative 6 is less than or equal to x, which is less than or equal to negative 1. This was a previous example. And we determined that our interval notation was this. We need to do our set builder. So our set builder notation is curly bracket x such that this part never changes. It's always going to be this. And then you just write out the rest. You can write it out, negative 6 is less than or equal to x is less than or equal to negative 1. You just write that in there. A lot of times on your homework, it's going to go ahead and give you this portion, and then you just finish it out. And it'll even have the other bracket on the end, and you just write this middle part in. So there's really not any difference. It's just, it has a special name. All right. Let's move on and do union and intersections. You're not really going to have unions and intersections on your homework. There's going to be one special one that you will, but you kind of need to have this as a precursor for Math 30 and for your college algebra courses coming up. So we're going to talk about it just so that you can, whenever it's brought up in another class, you can think, yes, I have seen that before. And then there is one problem out of this section. So first we need to know what these are. So union, the union of a set A and set B, and that's also written A with this U, B, so A union B, is the set of elements in set A or in set B. And words that might be a little bit confusing, but it's easier to think of union and intersection in terms of Venn diagrams. So the circle on the left is set A. The circle on the right is set B. So the union of A union B, is going to be anything that's in A or anything that's in B. So that means all of this is A union B. And you can sometimes see that written as A union B equals, and here's our set builder notation, X such that X is an element of A, and that's what this little symbol means, is an element of, or X is an element of B. With this little E thing meaning is an element of. Okay, so here's an example of what that means. If we say that the set A is a set of numbers that's 1, 2, 3, and 4, and we say that B is a set of numbers 3, 4, 5, 6, and we want to know what A union B is. So A union B is just everything that's in A and everything that's in B. So that means that set would be 1, 2, 3, 4. Now 3 and 4 are in both A and B, but we don't have to write them twice. We just write them once. 5 and 6. So A union B is everything in A and everything in B. Alright, so let's do intersection. The intersection of a set A and a set B, which is also seen as A and then kind of like the upside down U, B, is the set of all elements that are in both sets A and set B. Okay, so union was, it was either in A or B. Intersection, it has to be in both. So if you're thinking of the Venn diagram, then we have A and B. And the intersection is just the things that they have in common. So it's just this middle portion. So a lot of times you'll see that as A intersection B, and that equals X, such that X is an element of A and X is an element of B. It has to be an element of both of the original sets. Okay, so looking at our example up here with our set A and our set B, if we had A intersect B, what things do they have in common? Do they have 1 in common? No. Do they have 2 in common? No. They do have 3 in common, and they do have 4 in common. So A intersect B is just going to be the elements 3 and 4. And that's all we're going to really cover on union and intersection. And after we work a couple of problems, I'll show you why we covered that, because there's one problem that it comes up on. Okay, let's work a few problems. These are going to be slightly harder problems, and these are called solving compound inequalities using and or. So this is kind of why we learned the union and intersection. We're learning it so that we can do these compound inequalities with and or. Because and is the union and and is the intersection, or is the union. And is intersection, or is union. Okay, so here's an example. We have 3 is less than x, and x is also less than 5. So this is a compound one. So let's visualize this for a second. Here's 3, here's 5, there's 4. So x is, or 3 is less than x, so that means that's an open circle at 3, and then everything to the right of it is what we would shade in. Now over here we have x is less than 5, so that would be an open circle at 5, and then x is going to be anything that's less than 5. So that would be anything over here. So that means our shaded area would be everything in between here. Just like that. So do you think we can write that in interval notation? Hopefully you can. Our low is our 3, and we're not including it because it's just less than. And our high is our 5. And then we're not including it either. It has the open circle. So there's the interval notation for that problem. Now, do you think we can write it as a set builder? Where we have x such that. Do you think we can combine this all into one thing? I think you can. We have 3 is less than x, which is less than 5. And that's how you do the set builder notation for that one as well. All right. Let's do, so that one's the one with and. Let's do a problem with or, and then I'll work some of your homework for you. Example, we have r minus 2 is less than or equal to negative 6, or negative 4r plus 3 is less than negative 5. These problems aren't worked out, so that means we need to simplify these before we can actually play with them and get them in the right notations. So on the left, I'm going to add 2 to both sides, and that'll give me r is less than or equal to a negative 4, or I need to reduce this side. So I'm going to subtract 3 over. That'll give me negative 4r is less than a negative 8. I need to divide both sides by negative 4. I divided by a negative, so I have to flip my sign, and that'll give me a positive 2. So I have r is less than or equal to negative 4, or r is greater than 2. So let's go ahead and graph this so we can kind of see what this is talking about. Okay, so let's just graph this, this one on the left. We have r is less than or equal to negative 4. It's less than or equal to, so that means it's going to be filled in circle. And then less than is going to go to the left. So we're going to go to the left, like that. This one over here says r is greater than 2, so it's going to be an open circle at 2. And then r is greater than, which means we're going to go to the right. We're going to go on that way. So how do we write this as a set builder? Let's do set builder first. If we're going to do a set builder notation, that means we have r such that, and then usually we would just write this in, and that's really all you're going to do. You're going to say r is less than or equal to negative 4, or r is greater than 2. And that's how you would do a set builder for that case. You can have words in here. That's okay. It is okay to have that or in there. Your homework is not going to probably ask you for the set builder for this type of problem. They're going to want the interval notation, because the interval notation is going to use something we just did. Okay, if we were just looking at r is less than or equal to negative 4, let's do the interval notation for that. We would have the negative 4 is our big one, and we're going to use a closed bracket because it's less than or equal to, and then it can go all the way down to negative infinity. For the r is greater than 2, we're going to have 2 is our low, and we're not including it because it's just a greater than symbol. It does not include that. And then it goes all the way up to positive infinity. So our r can either be this, or it can be this. Up here, at the beginning of the section, I said or means union. So we need to put our union symbol in here. And that's your answer. I know that seems weird. Whoops. Negative infinity to negative 4. Union to negative infinity. But that means that our r value can lie either in this section or it can lie in this section. When it comes to the intersection in this case, which would have been this problem up here, we didn't really have to write that just because it lies in here, and we have another way of doing that. Theoretically, we could have written that out as an intersection thing, but it's just included in here. So this is a simpler way to do it without the intersection. Does that make sense? I wish you guys were here. We could have written this as 3 to positive infinity intersect 5 to negative infinity. Whoops. It would have been negative infinity, comma 5. We could have written it like that, which would have just been these two things written in interval notation with the intersection inside. But it's kind of messy, and this is just a lot easier over here. I hope that makes a little bit of sense. Again, you're only going to have one problem like this, and it's going to be like this problem right here. Okay? Where you're going to have an or, and you're going to have to use that union symbol. And I will work that with you on your homework here in just a second so that you understand. So, if you can, let's get your homework opened up, and it's going to be hopefully easier to understand. Okay, so once you get your homework open for 10.1, go to problem number 2. I'm going to work 3 total problems for you. And the first one we're going to do is number 2. And it says express the inequality first by using the number line, then by using interval notation, and then third as a solution set, which is the set builder notation. So our problem says -7 is less than x, which is less than or equal to -2. So we need to choose the best graph for that. So the first thing we need to look at is 7 is less than x. So that means that's going to be an open circle at -7. So that means it's not A, it could be B, it could be C, but it's not going to be D. So right there we know it's either C or B because it's got to be an open circle at -7. Let's look at our other end. We have x is less than or equal to -2. So at -2, does that need to be an open or a closed circle? It needs to be a closed circle. So we're looking at B, that's a closed circle. And if we look at C, that's an open circle. So C is wrong, so the answer would be B. So select B, check the answer. We got that right. Now we need to do interval notation. This is the one with the parentheses and things like that. So it's going to be as small as -7, but not include it. So we have to use parenthesis, -7. And then it goes all the way up to a -2. And we need a bracket. Whoops. A bracket there because it's including that -2. Hit enter. We got it right. Now express the inequality in the set builder notation. So this is the one where you don't have to do anything. You just have to put in the x, the vertical bar, and then you have to just type this out right here. -7 is less than, and don't forget about these symbols over here on the left side. So that's less than x, which is less than or equal to -2. And that is it. So on these problems where you have to do all 3, the easiest way is to just look at which ones of these needs to have their circles filled and which ones have their circles opened to help you eliminate that for your graph. The interval notation is the one where you do have to know whether to use parentheses or brackets. You use parentheses if it's less than or if it's greater than, and you use brackets if it's less than or equal to or greater than or equal to. And then to do the set builder notation, you just have to do the x with the vertical bar, and the vertical bar's over here, and then type out whatever they give you up top, if it's already reduced, obviously. So that's how you're going to do a lot of these problems. Was it number, I think it was number 11 I wanted to work next. Yeah, let's do number 11. And I'll pull up my page over here. Alright, so I'm just going to copy the problem down first. We have -35 is less than or equal to -5 times 2x minus 9 is less than 45. Now, when you're doing a compound inequality like this, the thing to remember is either you can separate this out into 2 separate problems, or the way that I think is easiest is to do it all as one. And so I'm going to show you how to do this all as one. So the thing we need to do first is just simplify this middle part. So we have -35 is less than or equal to, let's distribute in our -5. So it'd be -10x plus 45 is less than 45. Now, if we didn't have this part over here, that 45 part, the next step that we would do is we'd subtract 45 over, right? So we can still do that, but instead of just making sure we do it on both sides, we have to do it on all 3 sides. Because if we didn't have this part over here, what would we do next? We would subtract over our 45. So we can do it with all 3 things. So to get x by itself here in the middle, we're going to subtract 45 So that means we subtract 45 from the right side, and that means we subtract 45 from the left side. Okay? So that would give us a negative 80 over here is less than or equal to a negative 10x, which is less than 0. Okay? Now, to get x by itself, if we're just looking at this, what would we do? We would divide by negative 10. So if we're going to divide by negative 10 in one spot, we have to divide by negative 10 in all of them. So negative 80 divided by negative 10, which will give us a positive 8. But we divided by a negative number, so we have to flip the sign. So that becomes a greater than or equal to. Then we have our x. Again, we divided by a negative, so we have to flip. And that'll be 0. So we have negative 8 is greater than or equal to x, which is greater than 0. If you look at your problem over here, though, these are all written with 0 first, and that's because we usually write the lower numbers first. So we can rewrite this, though. If you look at it from this way, we have 0 is less than x. We're going this way. You're just reading the problem right to left then. And x is less than or equal to 8. Does that look like any of our answers over here? We have x is less than, and then less than or equal to 8. So let's do A. And we got it right. This is one of the harder problems because it's got both ends already attached, and you have to remember to flip your sign, and then you have to flip your answer. But hopefully you see how I did that one. If not, if this one is kind of a hard one for you, make sure you hit this similar exercise button down here, because see, then it'll generate a whole new problem for you that you can try again that works exactly the same way as that last one. Okay? But I wanted to make sure we went and did number 13. 13 is the one problem that's going to use the intersection, or excuse me, the union as part of our answer. So I wanted to make sure we worked through this problem together because I told you we would. So I'm just going to rewrite the problem. We have 5 minus r is less than negative 2. And, well, excuse me, it says or 8r minus 9 is less than negative 9. So really, when you have an or problem, it's just like working two separate problems side by side. So I'm going to do the left one first, and then I'll come back and do the right one. So we need to get r by itself. So I'm going to subtract the 5 over, which will give me a negative 7. That negative out front has got to go away, so I need to divide both sides by negative 1. But when I do that, I have to remember to flip my sign, okay? So I have r is greater than 7. Okay, and then over here, I need to get my r by itself, so I'm going to add 9 to both sides, which will give me 8r is less than 0. Divide by 8, divide by 8, and you get r is less than 0. And don't forget that or in there. So we have either, it says r is greater than 7 or r is less than 0. So let's write this as interval notation. R is greater than 7 is going to be in parentheses. R is going to be a bigger number than 7. So 7 is on our low end, and we're not including it because it just says greater than. But it can go all the way up to infinity. Or r is less than 0. So 0 is going to be on our big end. And it can get as small as it wants. It can go all the way down to negative infinity. Now the way I have this written right now is kind of backwards from how we would usually do it. We would write the smaller number, or the smaller set, on the left side. So we're going to write it as a negative infinity to 0. And then we'd write our 7 to infinity. So it's either going to be in this section or it's going to be in this section. And I told you or means union. So this is what we need to type in our answer box. Okay? And it's going to have all these symbols over here for us. So let's see if we can do that. And when I click on this, it's going to make that go away. I think I can make it. There we go. So we need to type in parenthesis, negative, and then our infinity symbols over here, comma, 0, parenthesis. Then we need to hit the union button, parenthesis, 7, comma, union, or excuse me, infinity, and close it. So that would be our answer. Check your answer. Actually, I'm not going to hit check it real quick. I want to see if we did it the backwards way, if it would give you guys credit. So let's see if we just typed it in the way that we had it written originally, if it would give you credit. Because I don't think it will. But we can test. Oh, it will. So you don't have to switch the order, but it is a nicer way to represent it mathematically, from least on the left to greatest on the right. But as you just saw, it does give you credit if you don't do that. So don't stress over that. This is the one problem though, and it does show up, I believe, on your final. So I mean, this is one of those to star and one of those to make sure you get on your cheat sheet if you're not sure about it. And again, if you need to work through it more times, hit the similar exercise button and just keep working it. It's a great practice and it's a great way to really understand how to do it. So good luck on your homework and good luck on your quizzes.